Hi guys, IBM is here with another episode of Learning Physics, and I think this is force density and pressure. This could be part 5. So without wasting time, let's go to where we stopped in part 4. I think in part 4 we stopped on page 32, and I want us to start from the same page. I'll change the color. So one end of a U-shaped tube is attached to a gas tap with its other end open to the atmosphere. It contains water of density 1000 kilograms per meters cubed, and the heights of both sides of the water column are shown. So let's see the diagram. So this is the diagram. The other side is open to the atmosphere, and this side is pressure from the gas is this side. The density of water is 1000 kilograms. The atmospheric pressure is 101 kilopascal. So the pressure this side is 101 kilopascals. So what is the pressure of the gas from the gas tap? So we want the pressure this side. So because the level of the water on the other side, on this side, has pushed the level of water to the other side, so it means the pressure this side, the pressure from the gas, the pressure from the gas, or the pressure of the gas is actually above the atmospheric pressure. So it is pressure of the atmosphere plus the pressure due to the height, which height is this one here, and this height is actually, I'll call it h, so plus the pressure due to the height of that liquid, which is equal to h density times g. So this is simply going to be atmospheric pressure, which is 101 kilopascals, plus plus the pressure due to the other one, which will be plus h. H is 31.4 minus 10.2, which is 21.2. So 21.2. It is in centimeters, so I'll say times 10 power negative 2. Then times the density, which is 1000. Then times 9.81. Remember, this was in kilopascals, so I'll also change this to kilopascals. So changing this to kilopascals, I'll divide this by 1000 to change it to kilopascals. So I'll just check with my calculator. 21.2 exponent minus 2 times 1000 times 9.81, of course divide by 1000. So I'll add that to 101. That gives us 103 kilopascals. So this is 103 kilopascals. That means my answer is going to be D. So because the liquid on this side has pushed, the pressure this side on the left hand side has pushed the liquid to the other side, it means the pressure of the gas is above that of the atmosphere. That's why we added atmospheric pressure plus the pressure due to the height h. Okay. A rigged circular disc of radius r has its center at x. A number of forces of equal magnitude F act at the edge of the disc. All the forces are in the plane of the disc. Which arrangement of forces provides a total moment of magnitude 2Fr about x? So 2Fr, that is the product of one of the forces times the perpendicular distance. Let me check. The radius is r, so the distance between the two is 2r. So which arrangement of forces provides a total moment of 2Fr? So if this is r and this is r, the moment due to this one is F times R, the moment due to this one is F times R, and both moments are clockwise, so this one gives us F times 2R, which is going to be equal to 2FR. That is the total moment, product of one of the forces times the perpendicular distance. So the answer is going to be A. This one gives a moment which is anti-clockwise, which is simply F times R. And these ones, this one gives a moment which is F times R, but this is anti-clockwise, and this one gives a moment which is F times R, which is clockwise. The resultant here is going to be equal to 0. This one gives a moment, which is F times R, and this is clockwise. This one gives F times R, which is clockwise. This gives F times R, which is anti-clockwise. The resultant here is only F times R, so the answer is going to be A. The diagram shows a uniform beam PQ. The length of the beam is 3 meters and its weight is 50 newtons. The beam is supported on a pivot 1 meter from end P. A load of weight W is hung from end P. The beam is in equilibrium. The beam is in equilibrium. So that means the resultant moment is 0. So the moment by the weight is anti-clockwise. Since the beam is uniform, its weight acts at the midpoint. Let me assume this is the midpoint. Its weight acts at the midpoint. And the weight of the beam is 50 newtons. So 50 newtons is acting there. And 50 newtons will cause a clockwise moment. So taking moments above the pivot, W times the perpendicular distance, which is 1 meter, should be equal to the weight, which is 50 newtons, times the perpendicular distance, which is this distance here. Because this was the midpoint, this is 1.5. The other side is also 1.5. So this is 0.5. So this will be times 0.5. So you just multiply 50 by 0.5. That is the same as 25 newtons. So our answer here is going to be A. In a high wire circus act, a man of mass 85 kilograms is standing at rest at the midpoint of the wire. Okay. So I'm just going to draw a horizontal line here for easy understanding. If I draw a horizontal line there, this angle is going to be 20 degrees. This will also be 20 degrees. The wire on either side of the man is at an angle of 20 degrees to the horizontal. What is the tension in the wire? So when the man is standing here, his weight is acting vertically downwards, and his weight is 85 times G, which is 9.81. So I'm going to resolve tensions upwards. This tension, when I resolve it upwards, to act upwards, and to be T sine of 20. The tension this side acting upwards will be T sine of 20. So I'll simply say twice of T sine of 20, because they'll point in the same direction, should balance the weight, which is 85 times 9.81. Okay, so I'll just press my calculator. 85 times 9.81 divided by 2 sine of 20. So I'm getting 1219, which is 1.2 kilonewtons. So T is 1.2 kilonewtons. So the answer is going to be C. A cylindrical block of ice of cross-section area 12 meters squared is floating, partially submerged in the sea. The density of the seawater is 1020 kilograms per meter cubed. A polar bear of mass 400 kilograms steps onto the block of ice. The block of ice sinks a vertical distance d. So the block of ice has sunk a vertical distance d. What is the value of d? So we know that pressure is equal to force over area, which is the same as h d density times g. So of course the force is going to be equal to the weight. So I'll make h the subject. H is simply going to be F divided by cross-sectional area times density times G. So F is the weight, which is 400. The mass is 400 for the polar bear. 400 times 9.81 divided by the cross-sectional area is 12 meters squared. The density is 1020. And then our G is 9.81. So I'll just press the calculator. 400 times 9.81 divided by 12 times 1020 times 9.81. So H is actually 0.033. So this is 0.033 meters, which is the same as 3.3 centimeters. So my answer is going to be B. An air bubble is rising through a liquid at a constant speed. Constant speed means acceleration is equal to 0, resultant force is equal to 0. The forces on it are the upthrust, the viscous drag V, and its weight W, which diagram shows the directions and relative forces of the and relative sizes of the forces. Okay. So of course they said it is rising. So the weight is downwards. The weight should not change, the weight remains constant. So since it is raising upwards, so the weight downwards, it is raising upwards, the forces acting upwards are the upthrusts. Upthrust acts upwards, that's one. The weight acts downwards, and the viscous drag, because it is raising upwards, the viscous drag must be downwards. So the viscous drag must be, the weight is downwards, the viscous drag must be downwards, the upthrust is upwards. So where viscous drag is upwards, I first eliminate that one. But it is moving at a constant speed, meaning that the weight plus the viscous drag should be equal to the upthrust. When I add the weight to the viscous drag, I should be getting the upthrust. So we just check the magnitudes. If you have a ruler, you can measure this length here, then measure this length here plus this length here. Without measuring, just by just looking at it using my eyes, I notice that this, when I sum up the weight plus V, I will get the upthrust. So the answer is going to be A. When I add these two, I will not get this line upwards. When I add these two, I don't get the magnitude upwards. So the answer is going to be A. A couple applies a clockwise torque of 9.0 Newton meters to a circular disc, which diagram shows the couple. Remember, a couple constitutes two parallel forces whose lines of action never meet. The forces should be equal in magnitude and in opposite directions. It is causing a clockwise torque. So this is clockwise, this is anti-clockwise. So we'll move this one, because these ones are causing anti-clockwise moment. This is causing anti-clockwise. So we'll move this one. So we have A and B. This is causing clockwise. So just check the magnitudes. For this one, it is going to be product of one of the forces times the perpendicular distance between the two forces, which is 0.5, and I think this is going to be 4.5 Newton meters. Check this one, product of one of the forces, which is 45, times the perpendicular distance, which is 0.2. This gives us 9 Newton meters. So it means our answer is going to be B. The answer is going to be B. Remember, A and B are causing clockwise moments, or the torque is clockwise, but then the magnitude for B is 9 Newton meters, yet for A it is 4.5 Newton meters. So the answer is B. A shelf PQ is attached to a vertical wall at P and supports a block. The shelf is held horizontally by a rigid bar XY as shown. The weight of the shelf is WS, okay, and the weight of the book is WB. The bar is at an angle theta to the shelf and exerts a force F on the shelf. So I will just prolong this for easy calculations. So this is F. This angle here is the same as the other one, so this angle is theta. Okay, the shelf is in equilibrium, resultant moment should be 0. What are the magnitudes of the horizontal and vertical components of the force of the wall on the shelf at P? So we just look at P. So at this point X, I'll resolve the force upwards. So resolving F upwards to be F sine of theta, and resolving F in the horizontal to be F cos of theta. So the force which is acting in the horizontal is F cos theta, and the force which is acting in the vertical is going to be F sine theta. Okay, so the question is, what are the magnitudes of the horizontal and the vertical components of the force of the wall on the shelf? The force of the wall on the shelf. So horizontal component, we have seen the horizontal component is going to be this one here, the component of F in that direction, which is F cos theta. So we eliminate sine theta, we eliminate C and D. Then the vertical component, vertically upwards, we have F sine theta, which points upwards. And then downwards, we have, because it is in equilibrium, then we have downwards, we have WS and WB, which are in the opposite direction. So these ones, I can sum them up, get WB plus WS. Because I just want a component resultant in the vertical. So the resultant force in the vertical will be WB plus WS, maybe minus F sine theta, or the other way around, it can be F sine theta minus WB plus WS, because these two act in the same direction. So that is the component in the vertical axis. So it means our answer is going to be W. This is F. Okay, our answer is going to be this one here. So the answer is B. F cos theta in the vertical, the horizontal, WS plus WB minus F sine theta in the vertical. So the answer is B. A solid cylinder of density rho C, cross-sectional area A, and length x is submerged in a liquid of density rho L. So density of the cylinder is rho C, cross-sectional area A, length x, is submerged in a liquid of density rho L. The upper face of the cylinder is at a depth h below the surface of the liquid, as shown. The acceleration of free fall is g, which expression gives the magnitude of the upthrust. So of course, upthrust is equal to cross-sectional area times difference in pressure between the top and the bottom of the object. So this will be cross-sectional area, difference in pressure will be density of the liquid in which it is submerged, which is density of the liquid, which is rho L times G. Difference in pressure will be difference in height. Of course, pressure is H, rho G. These ones, density of the liquid, G, acceleration of free fall, and H will be the height of the liquid, which is simply going to be X. So it means my answer is going to be A, rho L, Gx. So this is going to be D. So it means the density of the cylinder is not important here. The density of a paper is 800 kilograms per meters cubed. The typical sheet of paper has a width of 210 millimeters and length 300 millimeters. The thickness of a pack of 500 sheets of paper is 50 millimeters. Okay, what is the mass of a single sheet of paper? So we know that mass is density times volume, which is density, volume is cross-sectional area times another length, which I will call H, cross-sectional area times another length, and of course the cross-sectional area, this will be density, cross-sectional area will be width, this is height, so I will say width times length, then times height. So I will now substitute. The mass will be density, which is 800, times the width, which is 210 millimeters, which is 0.21 meters, times a length, which is 300 millimeters, that is 0.3 millimeters, then times, they said the thickness of a pack a pack of 500 sheets of paper is 500, so it means the thickness, which I'm calling H, is for one piece of paper is 550 divided by 500, which is 0.1. This is 0.1 millimeters. That is the thickness of one. So this will be 0.1 times 10 power minus 3. To change it to meters, so I'll just press the calculator. 800 times 0.21 times 0.3 times 0.1 exponent minus 3, which gives us 5.04 times 10 power minus 3. This is in kilograms. The answers have been given in grams, so I'll multiply by 1000. Sorry, 5.04 exponent minus 3 times 1000. That is 5.04, which is approximately 5 grams. So this is 5 grams, which means the answer is going to be B. The diagram shows 4 forces applied to a circular object. Okay. There are 4 forces applied to a circular object. Which row describes the resultant force and the resultant torque on the object? So let's check resultant force. In the vertical, the resultant force is 0. In the horizontal, the resultant force is 60 newtons, so it is not 0. So resultant force is non-zero, so we eliminate C and D. Then resultant torque. This torque is clockwise, it is cancelled with this one. So this one is cancelled out, but this one is clockwise, it is not cancelled out. So it means the total torque is non-zero, so the answer is going to be A. The resultant force is not 0, the resultant torque is not 0 because this causes a clockwise moment which adds to this one. Even though this causes clockwise moment is cancelled out with this one, so these two, the moment of these two cancel out, but this one is not, the moment of these other two is not cancelled out, so the answer is going to be A. In which example is it not possible for the underlying body to be in equilibrium? An aeroplane climbs at a steady rate. At a steady rate, it means resultant, here acceleration is 0, resultant force is 0, that is equilibrium. An aeroplane tows a glider at a constant altitude. At a glider, an aeroplane tows a glider at a constant altitude. So if it is towing a glider at a constant altitude, it means the altitude is not changing and is towing the glider. Most probably the acceleration here is remaining 0. The speedboat changes direction. If we see change in direction, then although the speed is constant but there is change in direction, there is an acceleration. So here acceleration is not equal to 0 because there is a change in direction. Therefore, this is not possible for equilibrium. So the answer is C. Blocks P, Q, R, and S are made from material of the same density. Block T is made from a material of twice the density of the material of the other blocks. The cross-sectional area and the height of each of the blocks are shown. Which two blocks exert the same pressure on the ground? So, of course, pressure is simply going to be force over area, which is going to be mass times gravity over area, and mass is density times volume, then times G over area. So, which two blocks exert the same pressure on the ground? So let's check the pressure due to the pressure here. The pressure here is going to be density. They have P, Q, R, and S are made from material of the same density, so the density is the same. So this is going to be density. Block T is made from a material of twice the density of that of the other blocks. Which two blocks exerts the same pressure on the ground? So I'll just check. So pressure here is going to be density times, of course, the volume here times volume times G over the area. Here the area is different, so this will not exert the same pressure. I'll just ignore these ones. I'll check R. R density is the same as this one before. Cross-sectional area is A, the height is 2h. I'll look at S. Cross-sectional area is this. Of course, because they are made of the same density, the bigger one, the one which has a bigger volume has a bigger mass, of course. So I'll just compare S and T. S will have density, pressure due to S will be density times Z2H times G, and the pressure due to T is going to be density of T, which is twice, because block T is made from a material of twice the density of the other one, so this will be twice rho. The height is H, then times G. So the pressure, this pressure here is the same as this one, so automatically the answer is going to be D. You can check the pressures of the others in comparison. So which two blocks exert the same pressure on the ground? So that is S and T. Because the density of T is twice the other density of the rest of the blocks. So times the height to the top times G. So the answer is automatically D. Two parallel forces, each of magnitude F, act on a rod of length 5d. Which diagram shows the positions of the two forces that will produce the largest torque on the rod? Largest torque. Remember, torque, these are constituting a couple. They will produce a torque of F. Of course, this is clockwise, this is clockwise. So the torque here is going to be F times D. Product of one of forces times the perpendicular distance. This is clockwise, this is anti-clockwise, so these ones are going to produce zero torque. They cancel out each other. So this is clockwise, this is anti-clockwise. The torque here is going to be zero because they cancel out each other. This is anti-clockwise, this is anti-clockwise. The torque here is force times perpendicular distance, which is twice d. So this is the largest. Product of one of the forces times the perpendicular distance between the two forces. Liquids X and Y are stored in large open tanks. Liquid X has density 800 kilograms per meters cubed, and liquid Y has density 1,200 kilograms per meters cubed. At which depths are the pressures equal? So we want the depth at which the pressures are equal. Okay. So pressure is equal to density times G times the depth H. Liquid X and Y are stored in a large open tanks. Liquid X has density this, and liquid Y has density that. So pressure is going to be equal to, so for liquid X, of course the question is at which depths are the pressures equal. So pressure is equal to that. So for liquid X, I will say this is going to be equal to the density, which is 800, times G, which is times G, then times the depth. Let me call this one H for X. Remember, this should be equal to for liquid Y, whose density is 1200 times G times its depth, which is H for Y. So G cancels out. So H, if I divide Hx by Hy, I should always get 1200 divided by 800. So I should get 12 over 8. Okay, so I just check. So 12 over 8. So at which depths are the pressures equal? So if depth for X is 8, then for the other one should be, I think, 12. Okay, maybe let me just say H for X is always going to be equal to 12 divided by 8, that is 12 divided by 8, that is by 4, that is 3 over 2, which is 1.5 H of Y. So H of X is always going to be 1.5 times H of Y. Okay, so let's check. If H of X is if H of Y is 20, H of X is not 8, so this is wrong. If H of Y is 15, 1.5 times 15, 1.5 times 15, that is 20 point, so this is out. If H of Y is 10, so this is going to be 1.5 times 10, that is H of X will be 15, so the answer is going to be C. From this expression here, I just check by inspection. If H of Y is 10, H of X is 15, so this is correct. You can check if H of Y is 8, so H of X will be 1.5 times 8, which is 12, so this one is wrong. So the answer is C. The density of water in 1.0 grams per centimeter cubed, and the density of water is 1.0 grams per centimeter cubed, and the density of glycerin is 1.3 grams per centimeters cubed. Water is added to a measuring cylinder containing 40 centimeters cubed of glycerin, so that the density of the mixture is 1.1 gram per centimeter cubed. Assume that the mixing process does not change the total volume of the liquid. What is the volume of water added? We have done this question, so I'll just solve it straight away. So total density of a mixture is equal to total mass of the mixture divided by total volume of the mixture. So it means 1.1 should be equal to, because mass is density times volume, the mass of water is going to be density of water times its volume, which is not known, so that gives us just volume of water plus the mass of glycerin is going to be the volume of glycerin times its density, so that is 1.3 times 40 divided by total volume is volume of water plus volume of glycerin, which is 40. When I solve this, I think I've already solved this. So solve this equation here. Volume of water is simply going to be 80 centimeters cubed. By solving this equation here, the volume of water is 8. We have already done this, so the answer is D. An astronaut throws a stone horizontally near to the surface of the moon, horizontally, where there is no atmosphere. Which law describes the horizontal and vertical forces acting on the stone after release? So there is no atmosphere. That's number one. If there is no atmosphere, it means first of all, there is no horizontal force acting on this, because since there is no atmosphere, there is no air resistance. So it means there is no horizontal force acting on the body. It's only gravity acting. So the horizontal force acting should be 0. So this A and B, we leave out A and B. Then How about the vertical force? The only force acting is gravity, and gravity acts towards the surface of the moon. And gravity is going to be constant. The weight is constant, so the answer is going to be C. A cylindrical block of wood has cross-sectional area A, weight W. It is totally immersed in water with its axis vertical. The block experiences pressures Pt and Pb at its top and bottom surfaces respectively. Which expression is equal to the upthrust? So we know that upthrust is equal to cross-sectional area times difference in pressure. Cross-sectional area difference in pressure. Pressure at the top is lower than pressure at the bottom, so it is going to be pressure at the bottom minus pressure at the top, which makes our answer to be B. Two forces, each of magnitude F, act in opposite directions on a rod. Each force acts on the rod at a distance d from the pivot. What is the torque? What is the torque of this couple? So this is clockwise, product of one of the forces times the perpendicular distance, which is d plus d, that is times twice d. So the answer is simply going to be, this is 2F times d. So the answer is C. The vector diagram shows three coplanar forces acting on an object at P. The magnitude of the resultant of these three forces is 1 Newton. Okay. What is the direction of the resultant force? Okay, so I'm just going to join these three. The resultant of these two, should be a force, which is here. The resultant of those two is a force which is there, and by Pythagoras theorem, the resultant here, I think it is 5 newtons for these two. That is, if this is 3, this is 4. So 3 squared plus 4 squared under square root, that is equal to 5 newtons. The resultant of those two is 5 newtons in that direction. So we have 5 newtons in that direction and 4 newtons downwards. So the resultant is again going to be 5 newtons minus 4 newtons, which is equal to 1 newton, and it acts in that direction because 5 newtons in that direction is bigger. So it means our answer is automatically D. 1 newton in that direction. The diagram shows a ball of weight W hanging in equilibrium from a string. Okay. The string is at an angle theta to the vertical. The tension in the string is T. The ball is held away from the wall by a horizontal force P from a metal rod. What is the relationship between the magnitudes T, P, and W? Okay, let's first go back here. So if I try to, I'm just trying to prolong this. Okay, let me do a vector triangle. Maybe if I begin with the vertical, which is the weight, and on the vertical I add this vector here, which is P, so this is W, then T is going to be this one here. So the question is, what is the relationship? So T is in the hypotenuse, so T squared is actually equal to W squared plus P squared using Pythagoras theorem. So what is the relationship between the magnitudes of T, P, and W? So T squared is equal to P squared plus W squared. So our answer is automatically going to be C. Four cuboids with identical lengths, breadths, and heights are measured in water. The cuboids are held at the same depth, and in identical orientations by vertical rods as shown. Water has density rho. Cuboid W is made of a material density 4 rho, X is of density 2 rho, Y is density rho, and Z is density 0.5 rho. Which statement is correct? I see all statements are about upthrust, so let me check. I know upthrust is equal to cross-sectional area times the difference in pressure, which is cross-sectional area times density times G times delta H. So they have the same lengths, breadth, and height, so this one will be the same for all. Cross-sectional area is going to be the same for all. G is going to be the same for all, so it is only density is the only factor which is going to change the upthrust. Okay, so the upthrust of the water on each of the cuboids is the same. The upthrust on the water, the upthrust of the water on each. Oh, this is density of the liquid, not density of, so the upthrust is the same. So the answer is A. Because rho is not the density of the cuboid, it is the density of the liquid. This is density of the liquid. So since the density of the liquid, they are all in the same liquid, the upthrust is going to be the same because the upthrust is depending on the density of the liquid, not the densities of those ones. They have the same height, acceleration to gravity is constant, same cross-sectional area. They are in the same liquid. So the answer is A. The upthrust of the water on each of the cuboids is the same. The upthrust of the water does not depend on the density of the cuboids. It is depending on the density of the water. So the answer is A. A rectangular block of lead of density 1.13 times 10 power 4 kilograms per meters cubed has sides 12, 15, and 10. What is the minimum pressure the block can exert when resting on a table? So pressure is equal to force over area, which is going to be mg, which is the weight, over the cross-sectional area. That is going to be density times volume times g over cross-sectional area. Since we want in pressure maximum, then the area must be smallest area. So the pressure is going to be equal to density, which is 1.13 times 10 power 4 times the volume. Of course, volume, I will multiply all these ones. So that is 12 times 15 times 10. Each of them is in centimeters, so I will say times 10 power minus 6 to change it to meters cubed. Then times G, which is 9.81, times the smallest area. I will just look for the combination of the smallest values. That is 10 and 12. These are the smallest values. So the smallest area is 10, 12 times 10. Because it is in centimeters squared, I'll multiply this by 10 power negative 4. Change it to meters squared. So I'll check with my calculator. 1.13 exponent 4 times 9.81 times 12 times 15 times 10 exponent minus 6 divide by 12 times 10 exponent minus 4. So this is giving me 16,627 or 16.6 kilopascals. This is 16.6 kilopascals. So the answer is going to be D. Full fat milk is made up of fat-free milk mixed with fat. Full fat milk is made of fat-free milk mixed with fat. A volume of 1 times 10 power minus 3 meters cubed of full fat milk has mass of 1.035 kilograms. It contains 4.0% fat by volume. The density of fat-free milk, that is like milk without fat, is given as this. What is the density of fat? So this is a mixture. This is going to be, this is actually a mixture. So The mass, I will use, which letter should I use? Full fat. The other one is full fat, fat free. So I will say the mass of free milk is going to be density, which is density of free milk, fat free, is 1.04 by 10 power 3. That is the density times the volume. The volume, they say it contains 4% fat by volume. So that means 94% is free. I mean 96% is free. So the volume of free is going to be 96%, which is 0.96 of the volume of full fat. So 0.96 times 1 times 10 power minus 3, that is the mass of free milk. And the mass of fat is going to be, okay, let me first check this one by the calculator. 1.04 exponent 3 times 0.96 exponent minus 3. So this is 0.9984 kilograms. So that is the mass of free milk. So the mass of fat is going to be the difference. The mass of fat is going to be 1.035 minus 0.9984. So I'll say 1.035 minus the answer. So the mass of fat is going to be 0.0366 kilograms. That is the mass of fat. Okay. So what is the density of fat? We have the volume of the volume of fat is 4%. So that is now very easy. So volume of fat is actually 4 over 100, or 4% of this volume here, times 1 times 10 power minus 3, which is 4 by 10 power, I think this is minus 5 meters cubed. So the density of fat is going to be the mass of fat, which is 0.0366 kilograms, divided by 4 times 10 power minus 5. So you have that one divided by 4 exponent minus 5. So this is giving me 915. So this is 915 kilograms per meters cubed. So the answer is going to be B, 9.15 times 10 power 2 kilograms per meters cubed. So the answer is B. Gas is trapped inside a cylinder by a piston of cross-sectional area A. The piston is not frictionless. It is not frictionless. The gas is heated and this causes it to expand, pushing back the piston through distance R from position P to position Q. The length of the gas column is S. Which expression represents the amount of work done by the gas against the atmosphere during this expansion? So of course we know that work done is by an expanding gas is pressure times change in volume. So this is going to be pressure times change in volume, which is cross-sectional area times the distance R. So it means our answer is automatically going to be A. So that part of the piston is not frictionless, it's just to confuse us, but it is going to be, because the piston moves through a distance R, so the work done is going to be atmospheric pressure times volume, change in volume, which is cross-sectional area, of the piston times the distance through which it moves, which is r. So the answer is A. A ladder rests in equilibrium on rough ground against a rough wall. The weight W of the ladder acts through the center of gravity G. Forces also act on the ladder at P and at Q. These forces are P and Q respective. Of course, these forces are the points of contact. They are normal reaction forces. So this is Q and this is force P. Which vector triangle represents the forces on the ladder? Which vector triangle represents the forces on the ladder? Okay. So the wall, a ladder rests in equilibrium on rough ground. The ground is rough against a rough wall. Okay. So there is a normal reaction there. Let me quote N at P, N at P. The normal reaction here, let me quote N at Q. Because the ladder can easily slide to the left, there is friction to the right. So this force is around here, which is force at Q. Because the ladder slides downwards from the wall, then the other force, which is friction, is upwards. So the force at Q must be in that direction there. So this is P. Maybe let me change the colors. So for normal reaction, we have this one here, and there is friction in that direction. We have normal reaction here, normal reaction at P. Because the ladder can only slide downwards, then the friction is upwards. This is friction. This was also friction. So the resultant here must be somewhere in between here. Okay. So which vector triangle represents these forces on the ladder? Of course, there is also weight at the center of gravity, which is vertically downwards. So have weight acting vertically downwards. Then there is this force from at Q. Then there is that force at P, which is in that direction. This is P. So the weight is vertical downwards. This is the weight W at G. Then this is the force from Q, and this is the force from P. So it means the answer is going to be, let's check. I think the answer is going to be A. The weight is that vertical downwards, the force from Q, the force from P. All of them are showing weight vertical downwards apart from D. So D is wrong. D is automatically wrong. And here it is showing a wrong direction for the force from P. This is also showing a wrong direction for the force from P. So the answer is A, because P points in that direction. Okay. Vertical tube closed at one end is immersed in water. A column of air is trapped inside the tube. The density of water is 1,000 kilograms per meters cubed. What is the difference between the pressure of the air in the tube and the atmospheric pressure? So the pressure acting on the liquid in the tube is due to the air above the tube above only. The pressure acting on the liquid in the tube is due to the air which is in the tube only. And also we know that pressure at any point, pressure is due to the liquid above that point. Okay, so if we know that theoretically, then we can say that pressure, we can find the pressure due to the air, which is going to be pressure due to this distance here is going to be, this is going to be 20 plus 30, that is at this point here, that is going to be 20 plus 30, pressure due to 20 plus 30 centimeters depth. of liquid, then plus we add the pressure due to the atmosphere because there's atmospheric pressure. So plus the pressure due to the atmosphere, which I'm calling PATM, that is pressure due to the atmosphere. So the pressure due to air is going to be atmospheric, minus, when I take pressure due to atmosphere the other side, so minus the atmospheric pressure should give me the pressure due to the depth of 50 centimeters, which I've got here, should be called the pressure due to a depth of 50 centimeters, which I've obtained here. So this means pressure of the air minus pressure due to the atmosphere is going to be equal to, for the depth of 50 centimeters, that is h rho g, this is going to be 0.5, that is 50 centimeters, times the density of the liquid, which is 1000, times g, which is 9.81, and I think this gives us 0.5 times 9.81 times 1000, so that is 4905. So this is 4905. So the pressure due to pressure of the air minus pressure due to the atmospheric pressure, or minus atmospheric pressure, is giving us 4905, which is approximately 4910 pascals. So what is the difference between the pressure of the air in the tube and the atmospheric pressure? So pressure of the air minus atmospheric pressure is going to be the pressure due to this height here. The pressure due to this height here. And this is giving us C. A uniform rectangular board is supported by a frictionless pivot at its center point P. Two forces act in the plane of the board. Force F acts at corner Q and force 2.5 F acts at corner R. The perpendicular distance between the lines of action of force F and point P is 20 centimeters. The board is in equilibrium. What is the area of the board? Okay. So let's first find this. So because it is in equilibrium, it means if I take moments about this point here, let me call this distance x. If I call that distance x and I take moments about this, so f is going to cause anti-clockwise moments and 2.5 is going to cause clockwise. So f times the perpendicular distance of 20 centimeters, yes, should be equal to 2.5 f times the perpendicular distance x. So it means x is equal to 20 divided by 2.5, which is 8 centimeters. So x is 8 centimeters, so this distance is going to be 8 times 2, which is 16 centimeters. And this distance here is 20 plus 20, which is 40 centimeters. So what is the area of the board? The area is going to be 40 centimeters by 16 centimeters. So 40 times 16, that is 640 centimeters squared. 640 centimeters squared. So this is C. Okay. I think this should be the end of this video part. Let part 5 stop on page 42. See you in part 6. I hope you have learned something from this part, and I hope you learn more in the next part. Do not forget to share the videos, share the documents in the video description with your friends, with your classmates. Download them, share them, and use them for practice. See you in part 6. Bye bye.